Hi everyone, Steve, G8NFZ, still here. This is part 4 of my 7-part series on basic operating of the ICOM IC7300. In this part, we'll look at the hardware first, and then some controls that affect voice modes and the sounds that you hear. Here are the basic specs of the rig. You see the modes. You can see the continuous frequency range for the receiver and the amateur bands in which you can transmit. There are 101 memories. It's acceptance of a 3:1 SWR. The power out readings for the various bands and how much power it actually consumes, what the thing weighs. The screen is a TFT Touch LCD 4.3-inch diagonal, and a little warning from ICOM: do not restrict the ventilation, the radio gets hot. The asterisk against 60 meters indicates that the frequency range is limited by ICOM to be slightly less than the actual UK allocation. It's only there on UK issued radios anyway, although I understand that French amateurs have just been allowed to use 60 meters, so they may get their own model in due course. Here are a few of the features that ICOM advertise for this radio and want you to know about. Remember that the ATU doesn't tune the antenna, it tunes the radio. Many of the controls are multiple function. IP Plus is a very special feature. Pressing, touching, and so on are all described exactly. And be careful with that screen. Sharp objects, including fingernails, could damage it. Whatever it is with this rig, you're almost bound to find that it's adjustable. There are 3,050 components approximately, and all the knobs and buttons are on the front. You can literally muck things up by overdoing it, but if you leave things at default, it will work. You're advised not to bother to try and take notes about this presentation. It's here, you can refer to it at any time. Let us start with a quick look under the bonnet. So what's inside the box? Here's a very basic level block diagram of the radio, showing that the functions are mostly dealt with on 4 main boards and a front panel unit. The main unit interfaces to all the others and provides the main logic and signal processing components. The RF unit does what it says on the tin, dealing with both transmitted and received signals, amplifying, limiting, and filtering as required. The tuner unit provides received signal processing and detection preparatory to digital handling, and a practically straight-through path for the transmitted signal. This is where the radio matches your 3:1 SWR antenna down to 1:1. The power amplifier unit provides those 100 watts of smoke and some serious low-pass filtering. And it's all driven from the front panel, which is where you come in. Here's the main board. Of particular note are the 3 LSI chips. The processor with 256 pins, the digital signal processor with 176 pins, and the field programmable gate array with 484 pins. They're all underneath. I've downloaded the manuals for these 3 chips. They total some 4,232 pages. Here's the RF unit. All of its tuned filters are switched using pin diodes. The tuner unit has a mass of relays, 25 of them. It remembers which set of coils and capacitors are needed for every 1.5% change in frequency across all amateur bands, provided you always make the same choice of antenna when working in a particular band, of course. And here's the power amplifier. There's a few more relays, only 15 this time, and the two main PA transistors. The eagle-eyed will have noted that there's not a single trimmable component in sight on any of the boards. It's all done with smoke and mirrors. All good stuff. Now we're going to have a look at see what's on the outside. Here's the back of the transceiver. Essential components we'll highlight in turn. Here's the 13.8 volt DC power input socket. 2 pins for each pole, giving connectivity resilience. It's quite a standard connector. Yaesu use it too. An earth tag here for your shack earth. The European version of the radio, which my club has, comes with a suppressor block with an artificial earth flying lead that goes here and is required by European standards. Here's the antenna connector. It's an SO239. No further comment. Here's the key socket for a standard 6mm, 1/4 inch, 3 conductor plug. Tip and barrel for a straight key. Tip, ring and barrel for bugs or paddles. The rig has a keyer built in, remember. Here's the speaker extension socket. Takes a 3.5mm mono jack plug. The remaining sockets are all concerned with attachments or computer interfaces, and that's another 2-hour lecture at least. I'm not going there in this series, perhaps a future project. Last I'm going to show is the fan. It starts at full pelt when you push the PTT. After that, the radio checks if the PA is hot, and if not, turns the fan down. Noisy, but nevertheless reassuring at the same time. Here's what the front looks like. There's a printable paper radio file downloadable for reference. Sorry once again, the paper ones don't actually work. Obvious feature in the center of the panel is the TFT touchscreen. We've seen some of its controls already, but for now I'll hide it. Now we can concentrate on the buttons and knobs. There are no switches, nor are there any controls on the top, bottom, sides or back of the radio. I'll cover all the controls in groups. The layout is good and similar to many other radios in terms of approximate location of functions. The first group I shall call the master controls. The second are the audio group for all the DJs amongst you. The third group are concerned with tuning, and we've seen all of these earlier. And the members of the fourth group control access to and the major functions within the touchscreen. The touchscreen does a great deal on this radio. This is a socket for an ICOM 8-pin microphone. Pins are microphone, 8 volts, up down, squelch, PTT, ground, microphone ground, and audio frequency output. Immediately above is a 3.5mm jack socket for stereo earphones. The audio is not, of course, stereo. This button is for power. Like all of the buttons, it's a soft button. That is, it does not switch the power. It instructs internal electronic circuitry to switch the power. The rig is live all the time that 13.8 volts are connected. This is a good thing because it keeps the real-time clock battery charged. If this goes flat, it can take a couple of days to recharge, although it will last a few months if not powered. If our club rig gets left disconnected for a few months, I suspect that questions would be asked. This button has a second function. A short press, rather than the long 1-second press required for power on-off, can be set to take a snapshot picture of the TFT screen. All of the screenshots in this presentation, except one, were captured this way. Next button down is transmit, sometimes known as MOX. Whatever else is set on the radio, as long as you're in band, this will cause it to transmit. There's a potential use of this to force transmission when we're set up for CW but haven't set braking. Button 3 is called tuner. It activates the internal tuner of the radio, which can adjust the internal circuitry to balance out a VSWR of up to 3 to 1. it does not tune your antenna. It tunes the radio to protect the PA. Your antenna is still just as awful as it always was. Button 4 is labelled Vox Braking. It enables Vox with a press, and with a press and hold allows Vox to be set up. For CW, it allows 2 levels of braking, that is, reception between transmitted signals, which we saw earlier. That completes the master control group. Hope we're okay so far. Our next group is the audio group, and this control consists of 2 concentric knobs. The outer knob adjusts RF gain and or squelch. You can choose for it to work as just RF gain, in which case the squelch is always open, or just squelch, in which case RF gain is always maximum, or by default as both. It normally sits at about 1 o'clock, RF to a maximum and squelch on the threshold. The inner knob is AF gain, extremely rare on this radio. That's the only job it does. This button enables and opens the settings for the noise blanker, aimed at pulse noise QRM. This one enables and opens the settings for the noise reduction system. It operates at the very first stage of the receiver. This is the notch button. There's an automatic notch and a very smart manual notch available for carrier removal and the like. This button adds 1 of 2 preamplifiers or puts the attenuator in circuit. All of these will be detailed soon. These 2 concentric knobs are for adjusting the IF frequency pass band. Each operates on a filter envelope surrounding the signal. The inner knob can also be pressed, like a button, to cancel the passband adjustment and return it to default. That's the audio processing group. This one's the tuning knob. Nice and smooth. The finger hole rotates so that it doesn't wear away your fingertip. The friction that you feel is set really nicely by the factory, and although there is here an adjuster, you shouldn't need to fiddle. This knob also has further function. It's used to set some parameters that require routine adjustment. More of that too. The tuning group we've already seen. These 5 buttons control access to many of the operations that use the TFT screen. They're called Menu, Function, M-Scope, Quick and Exit. Since they are so key, they will shortly be treated separately. Meanwhile, the last few items are this knob, which can be turned or pressed. It gets used for so many tasks that its name is a good one. It's called the multifunction knob. This is the transmit-receive LED. When unlit, the radio is squelched. When it's green, the radio is receiving, and when it's red, it's transmitting. As Count Orloff would say, simples. And this is the slot for an SD or secure digital card. It can store screenshots, audio recordings of your QSOs, logs of your RTTY contacts, pre-recorded Morse, RTTY and voice messages, the contents of your channel memories, all of your personalized settings, and can carry the files necessary for a firmware update when required. All of the files thus created can be copied to a PC, and most can be opened and or read by common PC programs. We've now seen all of the front panel controls: the master group, the audio group, the tuning group, the screen control group, and some of the human interface items too. Now we can move on. Here's the basic appearance again. Let's add a few features and break down where their indicators or icons appear on the screen. Here are those we've just seen: the VFO in use, the frequency, the mode, IF filtering, AGC setting, transmit permitted, the clock time, metering, and now we can add a few more standard items: Memory 1 here is available and contains a channel setting. It's a member of Scan Group 1, and up here there's an SD card in the slot. The spectrum scope has been enabled in fixed mode, fast scanning 3.6 to 3.8 MHz. Our current frequency is shown by a dashed line, indicated by the small R icon. The grid scale is 25K per division horizontally. The vertical scale is always 10 dB per division. The band is quiet, no signals appear on the scope or waterfall. Now we can go a little busier. Turn on preamp 1. Turn on the manual notch filter, the noise blanker, noise reduction. Set the tuning down to 1 Hz resolution and reduce the tuning speed to 1/4. Turn on the ATU, back off the RF gain, that raises a notification icon. Turn on full break-in to receive between Morse symbols. Let's adjust the IF filter and turn on split and use VFOB as the transmit frequency. You can't cram on much more than this. Anything else and something has to go. I'll work through how all of these functions are controlled and add a few more as we go. The manuals are very good at describing how to make changes. They don't necessarily say why you should or should not, however. Across the whole radio there are default settings, the great majority of which are perfectly okay, and for the remainder using the default won't be too far away from requirements. If you understand that settings can be changed, then in a club situation, for example, it will guard you against other users making unusual adjustments and not putting them back where they found them. Of the 5 screen management buttons, the rightmost 3 are the easiest to describe, so we'll get them out of the way first. This one is exit. For practically all functions, this one will back you out, normally 1 level at a time, and so may need several presses. It's a good button to remember. This one is called quick. It pops up a short menu of things you might want to do with the settings that you are currently using. Typically, it allows you to begin recording a QSO without making any other settings. They should already be in place anyway. Or you can choose which meter you want to see, and there are several to choose from. And this is M-Scope, Miniscope. It calls up a reduced version of the RF frequency scanning and waterfall display. We may use the term pan adapter from time to time. A longer press will expand it to a less mini scope too. Much more about this when we look at actual screenshots. When we turn on the radio, it begins with a welcome screen. Here's mine. You can have up to 10 characters where I have my call sign. In the bottom right, it shows the current internal computer firmware version, just for a confidence shot. It then flips the page to show the current power output setting. When I captured this, I had set it to 40%. Following this, it opens up the screen, showing whatever was the last setting that you used: band, mode, frequency, metering, and any other screen item that was current when you turned off the power. This is a very basic screen, and we'll now go on to see more screens and gain some understanding of what they're showing us and how they react to touch. Here's our basic screen. It shows 12 items. TX in red with a solid border indicates that this is a frequency within the set transmitter limits, amateur band or tighter. The border changes to dashed if you tune outside the limits, and a beep can sound too. This changes colour to white when you transmit. Just like that. LSB indicates the mode. The IF symbol is showing no adjustment. If the passband settings have been adjusted, a small white dot appears besides this icon. We're using filter 1, normally the widest of 3 for this mode. There's an SD card present in the slot. This flashes when the card is in use. This is the current time. You can set local and UTC. We're tuned to 3.650 MHz. The small white arrow indicates that we are currently tuning using one of the kilohertz tuning rates. We're using VFOA. The current and inactive memory slot is number 1. AGC is set to fast. It can be medium or slow, and how fast can be adjusted. The current meter in use shows signal strength, this one always shows, and power out in percent. This is selectable from a number of options, which we'll see soon. If you wish, you can display frequency using an alternative font. Personally, don't like it. And this screenshot shows you can also choose to see the alternate background color of the screen. Personally, not my favorite facility either. The screen backlight is also adjustable for comfortable viewing. Here is the meters screen. Simply touch and hold the S meter on the standard screen and these will appear. You have power out in percent, automatic level control, compression, voltage standing wave ratio, PA current, PA supply volts, and PA temperature. Note the limit lines. For ALC, this level should never be exceeded. If you're going over, then reduce your microphone gain. For driver volts, anything below 12 should be considered as a fault in your power supply. Anything over 16 may damage your radio. And for temperature, if you get near to hot, then reduce the output power setting. If the radio overheats, it will shut down. Touch the time and the clock panel appears. You can define local time and give a UTC difference if you wish. Touch the mode icon and the mode selection buttons appear. We've already seen these. Touch the filter icon to change the IF filter. There are 3 filters for each mode. This is single sideband filter 2. And this is SSB filter 3. As we've seen previously, a touch on the megahertz digit on the display causes the band stacking register to appear. And here I've touched and held the kilohertz digits and we see the step options we saw earlier. And I've now enabled 1 Hz tuning and locked the main tuning dial. Here you see what happens when you press the multifunction knob. Its default menu appears. The top item is nearly always power and is, as you see, selected by default. Turning the multifunction knob now sets the output power between 2 and 100 watts. By touching one of the other items, the knob can set those too. Normally these others should stay reasonably constant in the example, although levels are set, compression and monitoring are off. Monitoring allows you to listen to your own transmission. I wouldn't expect it to be switched on very often. Monitor can stay off for CW, as side tone is generated by default, and in fact side tone can optionally be turned down if you don't require it. A touch will turn them on. Here's preamplifier 1 turned on. You can see the boost in the S meter reading. The preamp is what it says in front of everything else, so it amplifies the noise as well as the wanted signal. Only a signal with a good signal to noise ratio will benefit. ICOM suggests that preamp 1 is used only on the lower bands. It appears to give about 20 dBs of gain. And here's preamplifier 2 with a further boost to the signal and the noise. ICOM suggests that this is only used on 50 MHz and above. It looks like about 30 dB gain is applied. Long press on the same button and the attenuator is now in circuit. The S meter has dropped to 0. This can be useful to tame overpowering local signals. The radio will tell you if it's being upset by a signal overpowering the digital processing stages. I've tried, but haven't found a powerful enough signal to do this yet. Now I've clicked the noise reduction button, NR appears under the Hertz digit. A long press goes to manual noise reduction, where the level can be set using the multifunction knob. And now the noise blanker has been enabled. NB appears under the tens of Hertz digit. To set the noise blanker levels, press and hold the button for 1 second. And the noise blanker setting menu pops up to allow adjustment. Level, depth and width are all adjustable with the multifunction knob. Remember that this is for pulse type noise. Be aware that overdoing the adjustments might also badly affect the wanted signal. Now I have the automatic notch filter in circuit. That's the first press of the button. The automatic notch seeks out any steady tone in the audio, like a carrier, and blanks it. Here's a screen showing the audio scope. The detail of how you get this will come later. The frequency spectrum is on the left and the oscilloscope trace on the right. I wanted it up now to clearly show the rather clever manual notch filter at work. Here I have pressed and held the notch button. MN appears under the 100 Hz digit. You can see the narrow notch in the audio spectrum. By turning the multifunction knob, I can alter position, which at the moment is centered on 2 kHz. By touching width, I can choose narrow, medium or wide. Press the multifunction knob to remove the menu, and here's the notch after setting. Just for show, I've now added noise reduction by pressing the NR button. See how the height of the audio scope waveform has diminished. The letters NR have appeared under the frequency. We now have manual notch, noise blanking and noise reduction all on at the same time. Other things pop up all over the screen. Here at the top left, we're informed that the antenna tuner is on. It can tune out the reactance of any antenna that presents a VSWR below 3:1. Not only that, but it remembers the setting and uses it for any frequency change up to 1.5% either side, so that if you always use the same aerial, it gets it right as you change frequency. Creating 21 settings will cover all bands. Memories can be cleared or overwritten if you change setup. Tuning is provided by 9 inductors and 9 capacitor groups, controlled by 25 relays. Be prepared for a heavy clattering session when you're tuning up. Over 100 combinations are checked if necessary. On the right-hand side, the split icon is showing, and below it is shown the frequency that will be used to transmit, in this case 1 kHz up. But remember that the split can be any frequency, including crossband. And here's a reminder of RIT showing a 100 Hz negative setting. The offset is adjusted using the multifunction knob. And here's delta transmit again. The transmitter will transmit 100 Hz higher. If you press and hold the delta TX button, then the frequency adjustment is applied to the channel and the delta setting disappears. If you touch and hold the filter icon indicated here, then the filter details will appear. This has several elements. The bandwidth of the filter is shown. Here it's 3 kHz. The shift of filter center frequency is given, for the moment, unshifted. The offset dialed into passband tuner 1 is shown on this slider. Passband tuner 1 is the inner PBT knob. The offset dialed into passband tuner 2 is shown on this slider. Passband tuner 2 is the outer PBT knob. The graph of the effective IF filter is shown here. The center frequency is currently 1.5 kHz. The BW button cycles through the 3 filters for this mode. While it is selected, the main tuning dial can be turned to alter the bandwidth of the filter. The range available is huge, from 50 Hz to 3.6 kHz. The modified bandwidth shows in the BW box, the filter number box, and on the graphic. The scale below the graphic changes to show the extents of the filter. The chosen or adjusted filter bandwidth is displayed here. Selecting DEF returns the filter to its default setting. The filter profile can be selected as sharp or soft. Soft is easier on the ear if there are no interfering signals nearby. Sharp can help to chop off any QRM. Here's the passband adjusted. The overall width is now 2.4 kHz, but this has been overridden by lowering PBT1 and raising PBT2, giving a final answer of 1.7 kHz. Because both have been moved an equal distance, the center frequency remains at 1.5 kHz. The range is from 650 Hz to 2350 Hz, which is the 1.7 kHz that's being shown. The three basic filters, filter 1, 2 or 3, that can be preset within limits for each mode are merely a starting point. If you want to be creative, any filter setup is possible. Note the little white dot to the right of the filter icon indicating that passband tuning is in use. It appears on both the icon and the expanded display. Touching the VFO indicator or memory number on the right brings up the VFO memory panel that we've already seen in an earlier part of the series. You are watching in order, of course. And so far, we're 140 slides in. According to rehearsal, about an hour and a quarter gone. Another 102 slides to go, about another 40 minutes. I hope you're still with me. Take a breather, then we'll hit the touchscreen main menus in part 5.